Recording now, this is lesson 4.4 on solving equations algebraically. Before watching the recording, please make sure that you have the 4.4 solving equations algebraically worksheet in front of you, along with a pencil, a highlighter, and eraser. So if you need to grab those items, please feel free to do so and pause the recording. But I'm going to continue first. So what I'll start off with is reviewing some vocabulary to know at the top of the page. So take your highlighter and let's just highlight these key terms that we did come across in a previous lesson. I'm just going to switch to the highlighter here. So the first vocabulary term that we're going to look at is equation. So just as a reminder, it's a number sentence with an equal sign. It's sometimes combined with letters or variables. So the examples I gave you, 2 times 5 equals 10. Now in that case, there is no variable. But in the second example, 2x plus 2 equals 4, that has a variable, but both of them are equations because there's a certain value given at the end, and you also have an equal sign. The next term, equivalent equations. Equivalent equations are equations that have exactly the same solution. For example, 2n equals 8 and 4n equals 16 are equivalent equations because n equals 4 in both equations. So that means when the variable has the same value in each equation, that means they're equivalent. In this case, n equals 4, so 2n equals 8, and 4n equals 16 are equivalent equations. The next we have variable. A variable is an unknown value represented by a letter, and you know that already. It could be any letter. The most common ones are x and y. Finally, the solution is a number that replaces the variable to make a true equation. So your objective in this lesson is to be able to solve equations algebraically. Okay, so let's continue. So there are 2 key rules to remember when you're balancing equations algebraically. So remember in the previous lesson, we were dealing with solving algebraic equations using algebra tiles. But in this case, we'll use a balance as sort of a metaphor. So remember we were mentioning in the other class the other day is whatever you do to one side, you have to do the same thing to the other side of the equation to maintain the balance. Okay, so remember if you're adding say positive 8 to one side of the equation, you have to add it to the other side to maintain your balance of the equation. Also too, remember the objective is to get the variable or letter on its own. You need to get rid of the other stuff or numbers around it and put them on the other side. You have to do the reverse operation to do this. So for example, if something is added to 8, you usually have to subtract 8 to make it go to 0. So oftentimes you're doing the opposite operation of the original operation. So this will make more sense later on. Okay, now the instructions are the following, and I'll walk you through the first 4 questions in terms of the procedure as to how to do this. So I'm just going to go back to my pen here. This should say solve for x in the following equations, and you're going to use the algebraic method. What I'm showing you on the video, you need to copy down step by step, and the expectation is that you're showing the same amount of work as I'm showing you here on the video. Now you may be solving these slightly differently than how I'm going to show you, and that's okay, but just make sure that you're showing all of your steps, especially as you're showing it in a 2-step equation where you have to do the second step. Now the first 4 examples are all 1-step equations. So let's start off with the first one. First we have x plus 3 equals 7. I'm going to recopy x plus 3 equals 7 here just so it's easier. Now, remember the objective is that we want to isolate x because we want to figure out what x equals, okay? Right now we have a plus 3 attached to it. So what I'm going to do is I'm going to use a different color, green, to show what I'm going to do. Now, because we have the plus 3 attached to it, we want to get rid of it and make it go to 0, so we have x on its own. Because it's adding 3, we're doing the opposite operation because we know positive 3 minus 3 will go to 0. Okay, whatever you do to one side, you have to do to the other side of the equation, right? Here we've canceled it out, and the way I cancel things out when I solve things algebraically is I cross it out and make it go to 0. Now, Some of you may be writing it horizontally like this, and that's fine too. I just find it's easier when you see it vertically. Some people like to write the -3 beside it, and that's fine. However, my preference, and you don't have to do it this way, I like to see things vertical like this, so I know exactly where my steps are going. So we know that, +3 minus 3 went to 0. We solve 7 minus 3 on the other side of the equation because we have to maintain the balance. That equals 4. Therefore, we're left with x equals 4. And then circle your final answer. Okay, that's how you solve a one-step equation. Now, you can check your answer by doing this. Remember, you can plug in or substitute for 4x by using brackets. We know x is 4 plus 3 equals 7. We know we're correct. Okay? Now, I encourage you to try number 2 on your own and try to apply the same method. Make sure that you're isolating x and you want to get the -8 to go to 0. Whatever you do to one side, you do to the other side. So pause it now before I continue if you want to try it on your own. But I am going to continue now if you're still watching. So I'm going to recopy x minus 8 equals -15. Now this time you have -8 attached to the x. We want to get rid of the -8. So again, I'll do this in a different color. I'm going to go +8 because I want that to go to 0. So it cancels out. Okay. Now, whatever you do to one side, you have to do exactly the same to the other side. So you're going to keep the same sign. You're going to go -15 plus 8. Now this is a good review of integer operations like what we did in a previous unit. Now, we solved -15 plus 8, which is -7. So we're left with x equals -7. And circle your final answer. Can you check your answer for this? Of course you can. So to check, now I'm not always going to ask you that you have to check your answers, but it's always good to do it to see if you're on the right track. Now this is where brackets become really key. Plug in -7 for x, put in -8, put in -8, which is supposed to equal -15. Now remember, you know you're right if this equation is true. If you think of it, remember that in our integers unit, -7, this is actually -7 plus -8, which equals -15. So you know you're correct. So x has to equal -7 in this case. Okay, so number 3. Number 3 is a bit interesting because now you have x over 12 equals 24. We haven't dealt with division yet in terms of isolating the variable, so I'll walk you through this step by step. I'm going to recopy x over 12, or x divided by 12 equals 24. Remember that this means a number divided by 12 equals 24. So we need to isolate x. Now this time you have x divided by 12. Think about what is the opposite or inverse operation of division. You know that it is multiplication. And so this is where you think about PEMDAS or PEMDAS, where multiplication and division are considered the same level of operation, mainly because they are inverse operations. So let's continue. Because they are inverse operations, what you're going to do is you're going to take x over 12, and I'm going to put this in brackets to signify I'm going to multiply it. Because remember, like I said, it's tricky if you have the multiplication symbol and the variable x in the same side by side. So I'm just going to write down beside it, over here, I'm going to write down times 12. Now, whatever you do to one side, you have to do to the other side. So I'm going to write down times 12 here. Now, here's what happens. When you multiply x over 12 times 12, these actually cancel out. So that actually makes it become 1x, okay? So you're essentially multiplying it by the denominator of the fraction x over 12. So you're left on the second line as x equals the answer to 24 times 12, which is, if you work it out, if you want to pause it and work it out, go ahead. It equals 288, okay? Now, so again, you're left with x equals 288. So if you want to check your answer and see if you're correct, what you're going to do is you're going to plug in, again using brackets, 288 for the value of x divided by 12. That should equal 24 if you do the math and you know you're right. X has to equal 288. And I forgot to circle my answer. Okay. So finally here in number 4, we have 9x equals 108. Similar to number 3, we're going to think of the inverse or the opposite operation. I'm going to recopy 9x equals 108. Just a reminder, this means 9 times a number, or 9 times x equals 108. So what are you going to do to get rid of the 9 times x? Think about the opposite operation of multiplication, which is division. So what you're going to do is you're going to divide by the same number. You're going to divide both sides by 9, because remember, whatever you do to one side, you have to do to the other side. You know that 9 divided by 9 becomes 1x, okay? Now, you have to do the same thing to the other side. So 108 divided by 9 equals 12. Therefore, x equals 12. Again, same process in checking your answer. So if you're going to check your answer, you plug in 12 for the value of x using brackets. So 9 times 12 should equal 108, which means the equation is true and your answer of x equals 12 is correct. Okay, with number 5, we have a two-step equation, and I think I'll only have time to do number 5 with you, so I encourage you to do the rest on your own. Now, in approaching a two-step equation, there's a couple of things you have to remember. So I'm going to recopy 4x minus 12 equals 48. Now, think of it as reverse PEMDAS, okay? So typically in PEMDAS or PEMDAS, we would do multiplication, division first before addition and subtraction. But because when we're solving x, or when we're solving for an unknown, we're working backwards, we're doing reverse PEMDAS. So we're actually going to do any addition and subtraction first before the multiplication and division. So we still follow the order, we're just doing it in the opposite way because we're solving for the unknown. So it's working backwards. Now, because we're working backwards, we're going to look at the minus 12 first. So as in the previous example, what you're going to do is you're going to take the opposite operation, you're going to add 12, so that goes to 0. Now, whatever you do to one side, you have to do to the other side of the equation. So you're going to add 12 to 48 on the other side. This is where showing your work is really important, okay? So I'm going to add 48 and 12. Okay, so then I'm left with, on the next line, I'm going to recopy 4x equals 60. I got that because I don't have minus 12 attached, it became 0. I'm recopying the 4x, and I'm recopying 60 because that's the answer to 48 plus 12. Now, you have 4 times a number equals 60. Think about the opposite operation to get rid of the 4, so it becomes x. You divide both sides by 4. This side, therefore, 4 divided by 4 becomes 1. And then you get the answer, and then you get the answer to 60 divided by 4, which is 15. Therefore, x equals 15. Now, it's the same process in checking your work for this. So if you check your work, and here you apply PEMDAS here, you plug in 15 for x. 4 times 15 minus 12 should give you 48. 4 times 15 is 60 minus 12, which equals 48, so you know you are correct. I encourage you to try the rest of the problems on your own following the same method.